Okay, moving on to 11.2, page 642, having to do with compound interest now. In 11.1, we dealt with simple interest. Now we are going to compound interest, meaning we're calculating the interest a number of times per year. So the N in this formula, all the other letters are the same as they were in 11.1. Final amount, principal amount, R is the rate, T is time. The only added variable here is N. N is the number of compoundings per year. And these are the most common N's. It can be any N, but these are the most common. If it's annually, if the interest is compounded annually, then N is 1. Semi-annually, N is 2. Quarterly, N is 4. Monthly, N is 12. And for some strange reason, the book uses 360 days in the year. I don't know why, but that's what we'll use because that's what the book uses. So if it says compounded daily, use N equals 360 in this formula. So here again, we have 1, 2, 3, 4, 5 unknowns in that formula. And we are given 4 of those unknowns. The daily part gives us the N, we have the T, we have the R, we have the P. So all we have to do here is plug this in number 8. We're looking for the final amount of money we have if we invest this amount of money at this rate, compounded daily for 5 years. So we're going to plug this in to the formula and get A equals 1,700 times 1 plus the rate as a decimal divided by 360 because it's days, and raised to the NT, so 360 times 5. Okay, 360 times 5, which is going to give us our exponent. 360 times 5 gives us 1,800. So our exponent here is going to be 1,800. Realize that is 360 times 5. All right, so we calculate that number. I will show you how to calculate that here. Let me see if I can get my calculator up. I believe I have it here somewhere under my applications. Here we go. Come on, calculator. There it is. Beautiful. All right, so we'll clear this. And what we want to do is work within the parentheses first. So I'm going to divide the 0.09 by 360. So 0.09 divided by 360. Remember our order of operations, we're working within the parentheses first. So that's this number. Now still within the parentheses, I'll show it to you when we get back to the screen, but we're adding 1 inside the parentheses. So add 1 to that result. Now this number is the number inside the parentheses. Order of operations, again, we do exponents before multiplication. So now we're going to raise, this is the button you use to raise a number to an exponent. We're going to raise that answer that we just got to the, what did we say, 1,800 exponent. So we're raising that to the 1,800. And now we have everything other than the principal amount. We're getting this many times the principal amount. So now we multiply by that principal amount of 1,700, and we get that final amount of 2665 and 98 cents. And that is going to be our answer. All right. So that is how we plug it into the calculator. Do this part first. Get the result, add 1 to it. Now you have what's in the parentheses. Raise that number to that exponent. Then you'll have all of this. Then multiply by the principal. And we get our final amount after 5 years, investing $1,700 at 9% interest, compounded daily. All right. So just another example here. Principal is 9,000, rate is 5.5%. This time quarterly, so N is gonna be 4. Okay, quarterly, N is 4. And for 3 years. So the final amount, 9,000. 1 plus the rate as a decimal over N is quarterly, and 4 times 3 is where we're going to get that 12, right? Negative, or N times T, 3 times 4, that's where we're getting the 12. So we calculate the same way we did before. We take the 0.055 and divide by 4, getting this value. Then we're going to add 1 to that. Now we have what's inside the parentheses. We raise that to the 12th. Now we have everything but multiplying by 9,000. We multiplied by 9,000, and we end up with $10,602.61. And give your answers a common sense check. I mean, $9,000, 3 years, quarterly, that makes sense. If you came up with a number less than 9,000, you know something's wrong. If you come up with 100,000, you probably something went wrong, right? So final amount, principal, rate, number of compoundings, T is the amount of time. This is how you compute the final amount when given that information with compound interest.